Hello math lovers, today's question is from geometry. 4 points M, N, O, P are chosen on the four sides AB, BC, CD and DA respectively of a square ABCD. If the line segment MN, NO, OP and PM are drawn, four congruent right angle triangles are formed. If angle NOC is 60 degree, what is the ratio of the area of the circle inscribed in the quadrilateral MNOP and the area of the circle inscribed in the triangle DOP? Okay, so we are given A, B, C, D as a square, and then we are asked to pick 4 points on the sides of this square in such a way that when we join these points, then we'll get 4 triangles, and these triangles are congruent triangles, that is they fit into one another perfectly. Then we find that MNOP becomes a quadrilateral. Now if this quadrilateral is a square or not, that we'll find out later. Then we are asked to find out the ratio of this big circle to the ratio of this small circle. This big circle is inside this quadrilateral, whereas this small circle is inside this triangle. It is also given that angle NOC is 60 degree. So now let's jump into finding the answer. So if it is given that this is 60 degree and they all are congruent triangle, so if this is 60, so this is also 60, this is also 60 and this is also 60. Now this is given right angle triangle, so if this is 60, so this comes out to be 30. So if this is 30, this is also 30, this is also 30 and this angle is also 30 degree. So we can write 60 degree here, we can write 30 degree here. Now DC is a straight line, so it is 180 degree. This angle is 60 degree, this angle is 30 degree. So we can subtract 60 plus 30, 90 to 180, and we'll get that this is 90. So if this is 90, this is also 90, this is also 90 and this is also 90. And since these all sides belong to congruent triangles and congruent triangle sides are all same, so these all sides are also same, and they all, this quadrilateral has a 90 degree in all its angles. So we can say that MNOP is a square. Now let's move to triangle PDO. In PDO we can take PD as 1. So when PD is 1, then we can find out DO. So to find out DO, we take DO equals to 10 angle DPO multiplied by PD. Now to understand this, let's take this angle. So for angle DPO, 10 will be opposite over base, so DO over PD. So this DO we can keep here, this PD we can keep here, so we can get 10 angle DPO, that is 60 degree, will be root 3, and PD is 1, so we can get that DO is root 3. Likewise you can also find PO. PO is DO over sine angle DPO, so you can consider here. So for here, sine will be opposite over hypotenuse, opposite is DO over PO. So we can put PO to the left hand side and we can keep DO to the right hand side, and it comes out in this way. So DO we have already found out to be root 3, and sine DPO, that means sine 60 degree is root 3 over 2. So if you simplify it, we get 2. So PO is 2, so we write this as 2. Now we'll find out the area of circle in the square MNOP, that is this circle. So the area of the circle is pi r square. Now here you can see that in this circle the side is length 2, so this circle's diameter will also be length 2 and its radius is length 1. So the area of the circle in square MNOP is pi 1 square. So area of the circle comes out to be pi. Now we'll find out the in radius of this triangle. That means we are going to find out the radius of the smaller circle. So in radius of triangle PDO is given by area of triangle PDO divided by the semi perimeter of this triangle. So area of triangle PDO is given by half multiplied by base multiplied by height. So we have a base as root 3 and height as 1. So we get this, and then we get perimeter. So perimeter is root 3 plus 3 divided by 2. So this comes out 1 over 1 plus root 3. So in case if you are wondering how this in radius formula is derived, I have already made a video on how in radius formula is derived. You can go and check that video out. Link is given on your top right. So we have found out the in radius of triangle PDO, that is the radius of the smaller circle. So now we can calculate the area of the circle inscribed in this triangle DOP. So we can take the formula pi r square. So area of the circle comes out to be pi 1 over 1 plus root 3 whole square. So now finally we can find out the ratio of the area of the circle inscribed in MNOP and the area of the circle inscribed in this triangle PDO. So the bigger circle has a area of pi and the smaller circle has the area of pi 1 plus root 3 over 2. So when we simplify it, we get 7.46. So the final answer is 7.46 is to 1.